This video provides step-by-step instructions for you to create this spacer plate using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to open Onshape and get started. In this segment, we'll review the engineering drawing for this part called a spacer plate. Let's start by identifying the views provided in the drawings. This drawing contains 2 standard views to fully describe the shape and the size of this mechanical part. First, the isometric view shows a pictorial. This helps us visualize the part in 3 dimensions. Next, the orthographic drawings are shown as flat 2D drawings, representing each of the 3 principal views shown here in third-angle projection. In the lower left corner, the front view. Aligned above the front view, the top view. Aligned to the right of the front view, the right side view. When preparing to make a feature-based model, we need to identify the basic shapes and features. The front view shows a rectangular shape. The top corners are cut at an angle, forming a chamfer. And the edges in the top view and right side view show the material thickness is the same throughout the part. The front view shows a circular hole centered on the plate. The hidden lines in the top and right side view show this hole goes through the plate. The front view also shows 2 equally sized smaller holes. The other views show these holes also go through the plate. The part is symmetrical, left to right. Next, let's look at the dimensions and notes. First, the measurement units are in millimeters. The material thickness is 10 millimeters. The front view shows the length is 200 millimeters. The height is 100 millimeters. The large hole has a diameter of 75 millimeters and is centered on the plate. The smaller holes have a diameter of 20 millimeters. The hole location is 25 millimeters above the bottom edge and 30 millimeters from the outside edge. The chamfer on the top corner starts 60 millimeters from the outside edge and ends 35 millimeters below the top edge. It is noted that the material is steel, and the mass units are set to kilograms. Before we model the part in Onshape, we have to establish our design intent. For this project, we intend our model to be flexible to possible design changes and update predictively without errors. To start, we need to identify all the features that may need to be changed or revised during or after modeling the part. First, the length may be changed to make it longer or shorter. Also, the height may need to be adjusted taller or shorter. And because the part is used as a spacer plate, the thickness will need to be variable to fit the application. Next, we need to identify the features that should remain unchanged when the variables are updated. In this case, the general shape should be maintained. The size of the large hole and size of the small holes should remain the same. The large hole should remain centered on the part. The small holes should remain in the same locations relative to the outside edges. Size and location of the filleted edges should remain the same relative to the top corners. The left and right symmetry of the part should be maintained when revisions are applied. When creating the model, the choice and order of placing constraints will determine if the model will change predictively. And if the design intent is applied correctly, we can revise the length, or change the height of the part, or change its thickness, and the model will update without errors. Before we model the part in Onshape, let's preview the steps in the modeling process. Use the drawing to identify the profile or closed shape that we'll use for the base sketch. For this spacer plate, we choose the front view. Because this is a flat part, this view defines all of the features and locations. Choose the desired isometric view orientation for the part in the Part Studio. We want the same orientation as shown in the drawing. So sketch 1 will be placed on the front sketch plane. Choose the location for the origin to constrain the sketch to the plane. We will place the origin coincident to the center of the part. That way the whole location and overall symmetry of the part can be maintained if the length or height is later changed. Complete sketch 1. This will be our base sketch. Extrude 1 will add the thickness and the base feature. Because this is a flat part, this step completes the model of the part. Looking at the feature list, notice that a variable has been used to set the thickness of Extrude 1. The variable is listed at the top of the feature list so that the value will be applied in features listed below. Looking at the setting in Extrude 1, the depth setting uses this variable. So if we change the value of the variable, the model will update. Create the base sketch. I've started a new Onshape document and named it SPACER plate. Before I start drawing, I want to check my workspace units. I want to make sure that length is set to millimeters and the mass is set to kilograms. Use the green check to accept. I'll start a new sketch in this part studio. Click to choose the front sketch plane. Use N on the keyboard to view normal. And use P on the keyboard to turn off the visibility of the sketch planes. Click on the rectangle tool in the toolbar and choose Center Point Rectangle. Click on the origin to constrain the center of the rectangle to the center of the sketch plane. Drag it out horizontal and vertical and click the mouse to accept. From the keyboard, enter 200 millimeters for the length. Use the Enter key to move to the height. And enter 100 millimeters for the height. Use the Enter key to end dimensioning. Use the Escape key to end the command. Notice that the lines are all black, indicating that the rectangle is fully constrained. Next, click on the Circle tool and choose Center Point Circle. Again, click on the origin to constrain the center of the circle to the center of the rectangle. Drag the circle and click again and enter 75 millimeters from the keyboard to set the diameter. Next, click in the lower right area of the rectangle to place the center of the small circle. Drag the circle and click. Then enter 20 from the keyboard to set the diameter in millimeters. Use the Escape key to end the command. To accurately constrain the small circle, click on the Dimension tool from the toolbar. Click on the center of the circle and then click on the outside edge of the rectangle. Enter 30 from the keyboard to set this distance. Click on the center of the circle again and click on the bottom edge, enter 25 from the keyboard. Next, we will use a line to create the chamfer that cuts off the corner of the rectangle. Click on the Line tool in the toolbar. Click and hold the mouse button to start a line coincident to the top edge of the rectangle and drag the line down until it is coincident to the right edge. Release the mouse to create the line. Again, click on the Dimension tool and click on the end of the line and the corner of the rectangle. Enter the distance of 60 millimeters. Set the vertical dimension for the line at 35 millimeters to complete the chamfer angle. By dimensionally constraining both small circle and the chamfer to the outside of the rectangle, they will keep their location if the length or height of the rectangle is changed. To make these features symmetrical to the other side, we will use a mirror tool. To use this tool, we need to draw a construction line at the center of the rectangle. Click on the Line tool, then click on the Construction tool. Hover the mouse over the origin to show a projected vertical line. Track up to just outside the rectangle and click to start the line. Stretch the line vertical to below the rectangle and click to end. Use Escape on the keyboard. Now, click on the Mirror tool. First, you have to choose a mirror line. Click on the construction line. Next, click on the small circle and the chamfer line. These entities will be mirrored on the other side. Right-click the mouse. Choose End Mirror from the pop-up menu. This mirror construction has created a symmetrical relationship between these items and the center line. This will enforce our design intent to keep the part symmetrical even if length or height is changed. The size and shape looks correct, so use the green check to accept the base sketch. Right-click and choose Isometric View from the pop-up menu. We can now create the base feature by extruding the sketch. Click on the Extrude tool in the Feature toolbar. This will be a new feature. For the region, click on the sketch. We want it to project forward and set the thickness to 10 millimeters. This completes the base feature, so click the green check to accept. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to kilograms and the material set to steel. If the size and shape of your model was completed accurately, the mass should be 1.009 kilograms. Let's look at this process step by step. First, open the document that contains the model of the spacer plate. Next, check the workspace units and make sure that mass was set to kilograms. Next, set the material to steel. I'll go to the part in the parts list and right-click and choose Assign Material. In this case, we're searching for steel. As I scroll through, I'll see that there's a number of types of steel available, but I want plain steel. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 1.009 kilograms. If this was your result, then your part is accurate and matches the specifications. If not, then you need to check Sketch 1 for proper dimensions and Extrude 1 for the thickness. In this segment, we'll apply a revision to our part called a spacer plate. First, we'll identify changes by reviewing the revised drawing. First, the length has been increased to 250 millimeters, and the height has been increased to 120 millimeters. Also, the thickness is now 25 millimeters. Please note, all other features should remain in their current size and relative locations. To start, I've opened my Onshape document called Spacer Plate. I'll start by revising the thickness. Double-click on the variable named thickness in the feature list. Change the current value from 10 to 25 millimeters. Click the Final button to preview. It looks correct, so use the green check to close. Next, the length and height were set in Sketch 1. Double-click Sketch 1 in the feature list to open the sketch. Use the N key to view normal. Double-click on the dimension for length and change from 200 to 250. Next, double-click on the dimension for height and change from 100 to 120. Click the Final button to preview. It looks correct, so use the green check to close. I see that our revised part has updated with no modeling errors. Let's check its accuracy by checking its mass properties. Click on the Display Mass Properties button and then click on the part. The revised mass should now read 4.485 kilograms. If this is your result, you have completed this project accurately.